Integration of ds is circumference. So circumference, how to find? 2 pi r. So what is r given? 2 centimeter. So I can write here 15 into 1 by 2 into 2 pi into 2. 30 pi. So how much is 35? 30 into 3.14.
2.14.
Give answer in decimals.
94.2.
That's it. Now next is conservative force. Now, what is conservative? What do you mean by conservative? Just word conservative.
From one body to another, it's conservative.
Yeah, it's conserving. Name itself suggests. So, a force is said to be conservative if the work done by it when moving a particle from one point to another point. Depends only on this point and not path. That day we saw an example, path followed. That day we saw example, like if I drew, I don't understand.
Sure.
Or not. No, it's not right. Okay, let it be. In short, if I like draw it again, if this is the point B and it's moving from A, it will just worry about these points. Doesn't matter if it is following this manner. A point, direction CD, E, and here B. It's reaching A to B by C, D, E, and B, or directly at B. Doesn't matter. It just matter points. That is what
Which is
conservative.
independent of path taken, right?
Yeah, it's independent of path taken.
Gravitational force, frictional force. Anyway.
Exactly. Then what will be non-conservative force? Just same way, depends on path
Path
followed.
taken.
Same thing. Okay. So let's go with energy. Or even if I say work done to lift a body which is mgh.
GH.
That will cover in potential energy. Energy. Energy, we know what is it? Capacity to do work. Again, this is a scalar quantity. What are dimension? What is dimension formula?
L2 T power minus 2.
M.
L2 T power minus 2.
Yeah, same as work. So here we are going to study only about mechanical energy. Other energy we'll study later on. Maybe in
Kinetic energy plus potential.
Yeah. Some more energies are the nuclear and all that. You will study in atoms and all that. So in mechanical energy, we have two. What are they? As you said, what?
Kinetic energy and potential energy.
Yeah. Now what is kinetic energy? Or just due to its motion, right?
In formula.
Due to its motion.
Potential is virtue of its position.
Yeah. Due to its position. Or in general, we can say height also. Now this both SI unit will be joules. Energy, wherever you get energy, that is joules. Joules. Lower power it is erg. In work only we discuss this one, right? So 1 joule equals to how many ergs? 10 to power
7.
Yeah. 10 to power of 7. Okay, so how to derive this? Do you know derivation, right? Or shall I derive this here? Okay. Expression for kinetic energy equals to half mv square. We need to derive this. So how we got this? By we started from acceleration. Consider mass and all that. I'm not writing that. You see when in your exam you have to write. It shows impression. Like consider mass m and moving with the velocity, initial velocity u. Okay, taking what distance s, displacement s. All these things you have to mention. Because this is what we are considering as A as acceleration, V as velocity. To us from first equation. And we know work done equals to force into displacement. It's not cross product, it's just multiplication. So force equals to mass into acceleration into displacement. If we substitute m v square minus u square by 2s into s. So m by 2 v square minus u square. That is a work done. Suppose at its initial point u is 0, means at rest. Object at rest is at rest.
V
That
square
means
by 2.
Yeah, that's it. If object has rest, at rest, u equals to 0.
0.
So we'll get w equals to half mv square. But we have to remember this formula only, because not every time an object will be at rest. So we can write general form as w equals to half m v square minus u square. We can remember this. So this is what work done in form of kinetic energy. So kinetic energy equals to half m v square minus u square. Final velocity minus initial.
In kinetic energy.
Hmm. Okay. So in short, this is what change in kinetic energy. Or I can write as W equals to change in kinetic energy. Here what we are doing, half mv square minus
Minus
half
mu
mu square. So final Ke minus
initial.
initial Ke. That is a change in kinetic energy. Array, disturb. Okay, fine. So next is work energy theorem. You have that in syllabus? You have that in syllabus?
Yes, sir.
Okay. So what is work energy? Name itself suggests. Go with the name always. What is work and
The
energy?
network then is
Yes, you say something?
network then of its forces is equal to its kinetic energy, changing energy.
Yes, exactly. So work done by a object which is converted to energy. That is work energy theorem or work energy concept, whatever it is. So if I add, like if I take this work done by a first object, it will be F1 by delta 1, delta x1.
F2 delta X.
Same way, if we go with n numbers, so I'll write directly W delta n equals to f of n.
N delta X.
Yeah. Then total work, if I want, work done, W equals to summation of,
Fn.
yeah, I can write here, no need to write here, then directly here, 1, that is n. N stands for 1 to n numbers. Yeah, because n is just index. N is just index. So in form of integration, a to b force dx. See, nothing we new we are doing, same formula we are using in different way. Okay, after this, what chapter do we have? What are chapters left?
And C, sir.
Huh?
C, sir.
Okay. Till then I write this question.
Oscillation, gravitation.
Oscillation.
Mechanical
Gravity.
properties of solids.
Okay.
Fluids, thermal properties of matter, thermodynamics, and kinetic gas of theory.
Only for solids, mechanical property of solids only, not
Fluids
fluid.
also, yes, sir.
Uh,
Thermal properties of matter, thermodynamics, and kinetic gas of theory.
matter, KTG.
Thermodynamics.
Okay.
Thermal properties of matter.
Yeah, that will be included in KTG.
Separately in our study.
Yeah, I'll do that. Okay. So when is your exam, by the way?
Which one is final?
Yeah. It will
April
include all this
20th, yeah, same.
this 28th this month,
Not this month.
next month.
Final one, sir, or pre-final?
Both. When is pre-final?
Pre-final is March 14th or 15th.
14th. And final?
Final April 20. Start.
April 20. Okay, so our target should be before this pre-final 14, right?
Yes, sir.
So we have this 14 days plus this 14 days, almost 28 days. Okay, if I take extra class, will you be available? Will you all be available?
Yes, sir, will be.
Because there are like 1, 2, no, 1, 2, 3, 4, 5, and if I include mechanical properties, thermal properties. So 1, 2, 3, 4, 5, 6, 7, 7 chapters.
Extra class means link Sunday, sir.
Maybe yeah, Sunday or some other day you don't have time, right? Other classes.
We don't have.
Yeah, even I don't. Okay, let's see. I'll talk to Manoj sir. Because I don't want to skip anything. Just
Yeah, but like in our college I also know it's started revision, sir. From starting.
oh, they started
Even
revision.
for, yeah, up to final also. Up to final they start. IP, only IP, no mains.
Okay. Fine. Okay. Let's do a question. A 50-gram bullet is accelerated to rifle barrel 72 centimeter long to a speed of 720 meter per second. Average force exerted bullet. while it is accelerated. They have given a hint as using perk energy theorem. That means it's directly given everything. Very easy, right? Mass is given, centimeter is given, that means distance. Speed is given. But we need to find force. So what we are going to do here, Fs and W equals to half mv square minus half m. Yeah, we'll compare this. F equals to this same value divided by S. Try this. I'll give you 1 minute to solve.
You can take U as 0.
Yeah, U was 0 because initially they didn't say anything. But don't forget to convert this. What about you? Are you doing, Devanshika? And Saintia?
Drawing it.
Okay. Done. Time up. It took 2 minutes. Is it that long? Guys, is it that long? Done, Varun?
You will get 6.3 Newton.
6.3. Did you converted everything, right? This centimeter to meter, then gram to kilogram. Then you should get correct answer. Okay, then might be book answer wrong. Let me calculate. Okay, so here what do we have? Half into mass. How much is mass? 15 to 10 to power 3 minus 3. Velocity is 720, right? 720 divided by distance 72.
Why didn't you distance?
Because we need to find force. To 36. So this 2 will go up and 15 to 10 to power minus 1 into 10 into 36. Did I miss anything? Oh, 360. Oh, I'm so sorry. Now correct, right? 360, 10, yeah. It should be
80.
18,000. 36 into 5. 180. So 180 then 1, 2. Correct. Because this will go with this one. So
Divided with this. So I got
So I can write this one as 1.8 into 10 to power 4 Newton in scientific notation. Yo, everyone got this? Both of you? Divanshika, Shainitya?
So actually had some calculation mistakes, sir. So
Okay, okay. Try again. You'll get this. What, sorry, what about you, Sainitya? Sorry, it's not Nitya. Sainiyati. I'm sorry. Okay. You didn't tell me. I was just pronouncing your name wrong. Huh, okay. Oh, Okay, let's do one more question. This time I want you to solve it anyhow. Two masses. I'm just writing directly. Two masses, 2 kg and 3 kg are connected at two ends of the light extendable string pulley are connected to a pulley. Two kg, 3 kg, fine. This frictionless pulley, okay, fine. The masses are held rest beside each other. Masses are held at rest beside each other and then released. Find the speed of each mass at the instant they both move 0.05 meters. Okay, solve this, come on. Again, here they give initial velocity as 0, right?
Is it extendable or inextendable?
Inextendable. It is inextendable. What else is given? Mass 1, mass 2, right? So we need to find V. See, shall I give you a hint or you're
Yeah,
getting
hint.
something? Okay. So if you observe, if they said speed at which, okay, wait, before that, masses are held at a rest beside each other and then released. So at instant, they both are at 0.05. So the distance between them, it is 0.05, right? That means this object, obviously it is mass more, that means it will go down and this will go up, right? That is obvious. So what will I do? I'll just first work done equals to change in kinetic energy. So here, final kinetic energy minus initial kinetic energy. Here, work done in form of its stored energy. So work done in form of stored energy, that is M GH. But what about this mass? Which mass we will take? 2 or 3? Here, okay, final we can say this mass, and initial we can say that mass. Means we can add both. Kinetic energy means we can add both, fine. It's not about height. But this potential energy is about height. So what we'll do there, and what we'll use on left and right? Which mass will use on left and which mass will use on right? That is the main question. Any idea?
I think final is 3.
3 meter per second?
3 kg like mass.
Okay. Mass. We'll use 3 kg on left side. Okay. So what do you think, Devanshika? We'll use both or we'll use just one?
So we'll use both, sir.
Both as subtraction or addition?
So addition.
Addition. Okay. What about you, Sai? If you can't, like, if your mic is not working, you can type also. No answer? Okay. Okay, let's read this question again. Two masses, 2 kg and 3 kg, are connected at the two ends of the light inextensible string that goes over pulley. Fine. That is a statement. The masses are held at a rest beside each other and then released. So first it is at a rest. That means potential energy. Now released. That means it is converted to kinetic energy. So when we are considering potential energy, we will take mass 2 minus mass 1 G into H. Here, final and initial half. We have two velocities are same. So m1 plus m2 of v2 or whatever v square. So half mv square. Here we will consider both. So 3 minus 2, that is 1 into 9.8 into what is the height? What's the height? 0.05 into 1 by, sorry, equals to 1 by 2, 5 into v square. So v square equals to, find out. So here let's erase this and let's write change in kinetic energy. Okay, so what is it? P square equals to 9.8 into 0.05 to it's 0.05, right? So V will be how much? Get this answer?
But 0.196.
0.196. That is V square. But we know 196 under root, which is 14. So here, if I square root this, what will I get? Will I get 14? Will I get 14 or not? We cannot get 14 here because
Something
it is,
0.4.
yeah. If I use 1.4 into 1.4, I'll get 1.96. Okay. 0.0196, then I can write as 0.14 into 0.14, I can get 0.196 because 2 decimals. Here also 2 decimals. So this won't be 14, it will be 0.4 something.
0.4.
Okay, let me know, like, are you allowed to use calculator in your school, your college?
Sometimes, like when we are doing, we use by phones or time we use.
No, in exam.
Exam notes, never.
Sorry?
Exam notes,
No.
they won't allow.
Okay. Very good. That means you should learn this division and all. Okay. Now, as we saw kinetic energy, now let's see potential energy. What is potential energy? Energy possessed due to position.
Question, sir.
Energy possessed due to its position. Okay, can you give some example? Any example for potential energy?
Water behind a dam.
Yeah, that's standard example, yes. Water on a dam. Right.
Car parked at top of a hill.
I'm sorry?
Car at top of a hill parked.
Okay. Yeah. So delta U is denoted as, it's notation for potential energy.
UMGH.
Or if I write here du equals to F dx. Limits A to
To be.
B. Do you have this all derivations?
I think yes.
Right? Okay, then let's derive this. Screen froze or what? Yeah, okay. So we know, like we saw that conservative force, right? We were talking about conservative force before. So your total force on any object equals to force applied or conservative force plus applied force. And even work the energy theorem, we saw force into displacement equals to change in kinetic energy. Delta K is change in kinetic energy
We can.
from work energy theorem. This is conservative force. F. F is conservative force, FA is applied force, FT is total force. So I can substitute all this thing here. F plus FA into delta X, which is equals to delta K. So I can write F of A delta X equals to delta K minus this F will go that side into delta X, so F into delta X. I'm just following mathematical steps, that's it. So F, but here we need to introduce potential energy. So F into delta X. What was F? Conservative force. So this conservative force into sorry, conservative force into displacement or distance, that is potential energy now with the height. So F delta X equals to, let's take minus here, let U. So F of A delta X equals to delta K plus delta U. So what did we say? Delta U equals to minus of, yes. Yeah. Now if we differentiate with respect to X, so du by dx minus of X, sorry, F and dx. I can say here, this one, I'm changing it here. Fine. So therefore, F equals to, let's take this as a F vector equals to minus du by dx. From here, we got that equation. If we send this on that side, it will become du equals to minus F dx integration. That's it. With the limit, lower limit to upper limit, sorry, A to B. It's going A to B. No, if we deals with like a potential energy due to gravitational